Hello, I'm Lee. In this video, we are going to explore Java core collection interfaces. So, the first thing, what is interface in Java? Is that user interface? No, it's totally different. It's a new concept. Interface is sort of like class. The big difference between interface and class is interface has no trace of implementation. The similar thing is they both create a new data type. For example, here we have public interface. You see, we use the keyword interface instead of class. We create an interface called a collection. Actually, this is an existing interface in the Java API, and this is called a generic interface because it takes in a generic data type. So imagine this E as element or something you want to think about. It's just a type holder. So it could be a collection of integer. So in that case, it's integer. If it's a collection of students, then it's a student. It could even be a collection of other collection, then it's a collection. So it's just a type holder. Alright, so the interface name is called a collection. And within those curly braces, take a look, we only have a bunch of method prototypes. End with semicolon. Semicolon means we don't want to implement it. So that's the uniqueness of interface. They have no trace of implementation. They're pure contract. And contracts is important in OO programming. We have a slogan in OOP called always programming to the interface instead of the implementation classes. What does that one mean? We will see. Alright, so now let's take a look at the core collection interface in Java API. We have two trees. So the first tree is a collection tree with the root interface as a collection. You see collection, set, list, queue, and sorted set. They are all interfaces. Here we are talking about the interface hierarchy. So collection is a root interface. Pretty much it says I'm trying to model a collection of something, a collection of E, the element, a collection of something for you. And the set, list, and queue, they're most specialized collection. The relationship is called is a relationship. So set is a collection, list is a collection, queue is a collection. And when you go up the hierarchy, it's more general. When you go down, it's more specialized. For example, set is a collection, but set stress on unique elements. It's a collection of unique elements. So it stress on uniqueness. And list is stress on order. So it got sequence. Every element in this collection got a position. So it's a position-based interface. So for example, it starts with index 0, 1, and 2. So there's a sequence there. But it doesn't stress on uniqueness. It could be I have duplicate elements in the list, but it's not possible to have duplicate elements in a set. And for a queue, it stresses on first in, first out order. So you see, those are just specialized collection. Now when you look at this tree, so sorted set is a specialized set. So not only sorted set is stressed on uniqueness, it also stressed on order. So it's sorted. Alright, so when do we use what? So you take the data structure class, so that's a great thing. Now, the good thing about this class is you don't need to write any implementation class. You don't need to implement your own hash table, your array, and your linked list, but you need to know the advantage and disadvantage of using those data structures. We have all those implementation classes in the API, but as a user, you need to think about your application and pick the wise one for you. Alright, so let's take a look at a set. So when do we want to choose a set interface instead of a list? Again, it's about uniqueness. For example, it could be a deck of cards. So a deck of cards, every card is unique. That could be a good example. And for a list, It could be a list of integers, so there's duplicates in the list, or a list of names. There could be duplicates in the list. And for a queue, it could be a bunch of jobs waiting for the printer, some printing job. You want that first in, first out order. Alright, now let's move on to this hierarchy. This hierarchy is a map hierarchy. Sometimes people got confused. People think map is in the collection tree as well. No, they're two separate trees. Okay, so what's a map? A map is kind of like the hash table concept. So map stress on key value pair, so it's a collection of key value pair here. For example, a phone book, so the searching key could be the name and the value could be the phone number. So that's an example of map. And a sorted map is just sorted by the key. So most specialized map, it is a map, but it's a specialized map. And how to convert this map tree to this collection tree? The Java API provides a very nice way. So for map, it provides a method that allows you to return a set of map entries. So a set of map entries, then you see you get a set. And once you're a set, you can use everything in this collection. We will take a look at that one later. So the Java API pretty much got three big components: the two interface hierarchy and the implementation classes. We will talk about the implementation classes in a moment. And the third one is the algorithm part, and we will talk about the algorithm as well. So pretty much when you do the two hierarchy, the API allow you to convert the map into the collection because the algorithms are kind of used to process the collections. So now let's think about the implementation classes. Here, interfaces by themselves are useless because they're pure contracts. They don't have implementation. So we have to have classes to implement those interfaces. There's no class that implements collection directly. For set, it has three different classes. One is called a hash set. So you can imagine it's using a hash table to implement the set. And another one is called a tree set. So it's some kind of tree, and it should be a balanced tree. It could be a black-red tree or two, three trees. So we have a tree set and a hash set to implement the set. So when do you want to choose which implementation class? It's kind of obvious which one is more efficient. You should shout it out right away. It's hash set. Because hash set, the retrieval performance could be big O1, and the tree set is big O log 2 to n. So tree set got significantly slower than the hash set. So lots of the case we pick hash set. But if you really want that order like ordered by the value, then you have to pick tree set. And there's something in between called the linked hash set. So hash set is a total chaos, and linked hash set provides some order. So you can imagine you have a hash table and you have a linear linked list to keep track of the insertion order. So that's a linked hash set. So the performance of linked hash set is somewhere between the hash set and the tree set. So it maintains some order, but not exactly the value order. It's just the insertion order. It's pretty easy to maintain. So we have three implementation classes for set. And for list, we have two of them, the array list and the linked list. And you know the biggest advantage of array list, that's direct access to individual elements, unbeatable performance. And the disadvantage, it's too static. So if the list is very dynamic, you're going to pay some price. For linked list, on the other hand, it's very dynamic, but retrieval for individual element, the performance is much worse than array list. And for queue, we have linked list to implement a queue. So now let's come back to that concept of programming for to an interface instead of a implementation class. Imagine if you say I use a linked list. If you say I have a linked list, you declare it as a linked list, then people don't know exactly, are you trying to implement a queue? Are you trying to implement a list? Because a linked list as an implementation class implement both list and queue. So, but if you say I have a list, then the intention is very clear. You want a list. If you say I have a queue, then the intention is very clear as well. You want a queue. You want that first in, first out feature. So now let's take a look at how to make that happen, programming to the interface. So if I want to model a student list, I declare the type as list student. You see, I program to the interface. Then when I instantiate, I cannot say new list. It won't compile because list isn't an implementation class. So when I instantiate, I have to give it a concrete class, and that's array list because array list implement a list. And in the later code, student list, when I invoke some method on student list, the compiler will check those methods against the list interface. So it won't consider me as a specific array list. It will consider me as a list. It will consider student list as a list. So it will do the checking against this list interface for you. So that's very nice, because later on, if you realize this list is very dynamic and you regret the choice about using array list, then you know you only need to modify one line. That's here. You change it to a linked list, and all the other code, because you program to list, you don't have to modify those code at all. So it's very nice. And so for example, for map, if I want a student map and I want to, the key will be the name of the student or the ID of the student, and the value will be the student object. So the map type will be map from a string to a student. That's a student map. When I instantiate this map, I have to pick an implementation class. I pick hash map because hash map is more efficient, and another choice will be tree map. If I don't want that order, like ordered by student name, I won't pick hash map because of the unbeatable performance here. So new hash map, then string map to student. So I cannot stress more programming to the interface. Declare your object as interface type and only use a concrete class when you instantiate. Alright, so about the Java core collection interfaces, here are the two trees, and we talk about the implementation classes, and we will also talk about the algorithm classes later. But how do you find help? Let's see, come here. If you type Java API and click on this one, the collection interfaces are defined in the package called java.util, stand for utility. So Java is a big package, and under this big package we have utility package, lang for language package, and java.util contains the collection interface, the list interface, the set interface, and the map interface, and the implementation classes. You will work with this package a lot. Thank you. In the next part of the video, we're going to look at some code samples.